Hi, this video we're going to look at the 2D resultant force again. However, we are bringing reinforce the concept we talk about the IJ form, which is unit vector for x and y component. Now let's take a look. The first question is said resolve f along x and y and write in a vector form. So anything when you write down f, so here I'm going to introduce this. I call that a hat. So whenever you have hat on a force, which means this is a vector, it has a direction. So that's a direction that has a vector. It's a vector form. So that's going to be equal to fx component x then times the unit vector, since unit vector has magnitude 1, right? So this is just going to have a magnitude fx and it's on x direction. Then we're going to, this is a vector addition, so you have fy and j is unit vector for y-axis. So that's how we're going to decompose and write as a vector form. So in this problem, F is 80 Newton, and if you were trying to decompose to x direction, that will be going to the left. Going to the right, and then this will be going downward, right? So that's going to be our fx, fry. If you still want to draw a rectangle, you may. But, often I just no longer draw that anymore. So fx, if that angle is 30, this angle will be 30 fx. With respect to this 30 degree, this is opposite, so that's going to be sine. So it's 80 times sine 30 degree. And this y, respect to this 30 degree, this is adjacent, so it would be 80 times cosine 30. However, consider the sign, and this is going what? Downward, so that'd be negative. This one is going to the right, so it would be positive, because it's on positive x-axis, and it's on negative y-axis. So knowing that, we can just plug it in and you know which one would be right? So 80 times sine 30, so it would be those two, and however y direction is negative 80, so this C will be your correct answer. Okay. So this is basically just decompose problem. Now let's look at problem 2. They say determine the magnitude of resultant of those two forces. All right, so you have two forces, and this will be force 1, x component, and this will be force 1, y component. This will be force 2, x component, and force 2, y component, because it's all originated from there. So in that situation, in order to find the resultant, we can simply do what? We can add resultant at x, using the concept we use for decompose method. Step 2, right? Add all those forces together at x direction. So we'll have 10 plus this 20. That's all x component. That'd be 30. Now we're going to do the same thing. Add all the y component together. So in that situation, I'll have this 20. Then add this y component for F2, that 20. Add together, I have 40 Newton. Then we need to combine them because we need to find the resultant force of those two. So we're going to, using our Pathogram Theorem, so resultant is going to be this equation again. So it would be 30 squared plus 40 squared. We know 3 and 4 make a triangle. It's a right triangle. 3, 4, that'd be 5, right? Because 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 equals 25. So you can scale it up because times both 30, 40, that would be 50. So this answer will be giving us 50. When you say 3 and 4, 5. So that'd be 50 Newton. Then we know the answer is a C. For this problem, is relatively easier than the regular 2D component. Why? Because we don't need to do the first step. Because they already decomposed for us already. They already basically tell you fx and fy already. So basically get rid of that table we make normally. So it's given. We can just directly skip to step 2. Add all the forces at x, all the forces y, and then figure out resultant. That's all. Okay. All right. I'll see you on the next one. Bye.